Chapter 5 review. Here is number 10. So with this problem, we have 48 to the 1/4. So if you can't read that, that's a 1/4 over 3 to the 1/4, and then all to the 5th power. Now with this is that we can use the power of a quotient property. So remember with the power of a quotient property, if you have a over b raised to the mth power, we can say it's a to the m over b to the m. Now notice that properties can go forward and backward. I don't want to say forward and backward, but they go both directions. And so what we could do is if we notice that we have the same exponent, then we could put it on the outside. So maybe looking at it in this way, so it's a to the m over b to the m, we could rewrite it so it's a over b raised to the mth power. So if they're the same exact exponent, which it is here in this case, what we want to do is just push it to the outside. So this is what we'll do. So this will become 48 over 3, and then I'm pushing that 1/4 to the outside, 1/4. And so what happens is there's already an exponent there, so it's going to multiply to whatever is there. So it's going to multiply to that 5. So why that's important is because 48 over 3, we can divide 3 into 48 perfectly, right? 3 goes into 48, 1, and then 16 times perfectly. So therefore, we can change this 48 over 3 to 16, and then let's multiply the 1/4 times the 5. So 1/4 times really 5 over 1. So when you multiply fractions, you multiply straight across, and so it's 5 over 4. 5 over 4. And so we've done problems like these. This is like example 7a, which I don't have the answer up here, but you rewrite it so as an nth root to help you evaluate it. So remember again that the number in the denominator is the nth root, so it's going to be 4, 4th root of 16, and the 5 stays at the top out here. So now we can evaluate 4th root is 16, so we need 4 of something. So remember, 16 is 4 times 4, or that breaks down to 2 times 2 times 2 times 2. So it comes out perfectly as just a 2 to the 5th power, just like that last question. So 2 times 2 times 2, 2 times 2 times 2 times 2 times 2 is 32. So let's look at number 11. We have cube root of 27, x to the 7th, y to the 4th. So we need 3 in order for something to come out perfectly. So you need to show your full work. So cube root 27 is 9 times 3, or 3 times 3 times 3. I'm going to go ahead and write it as just 3 to the 3rd power. X to the 7th, so I just need that to be, you can rewrite it as like x to the 3rd, or I like to think about it as x to the 6th. Okay, because I know that I'll just have 2 that come up perfectly. Then we have a single x. 3 goes into 14 so many times. So 3 goes into 14, I know about 4 times. So 4 times 3 is 12. So I'm going to write it as y to the 12th instead. And then I have 2 more left over, right? So remember 12 plus 2 is 14. And then 6 plus 1 is 7, right? So I didn't really change it. Now that's just kind of a shorter way to write it. How I look at it is I know, okay, 3 goes into 6 2 times. Now, if you do it the long way, you could do this as well. You could say x to the 3rd, x to the 3rd, x, y to the 3rd, right, in groups of 3. 3, so I'm trying to get 14. So 3 times 4 is 12, y squared. So you can do this as well, and then circle it. So I'm just going to show you why my shortcut kind of works. Okay, so I'm going to take all my, everything with the 3rd power out. So what's going to happen is I'm going to have 1, 3, 2 x's, 1, 2, 3, 4 y's, and then what's left is there is an x and a y squared left. So if I simplify, I get 3x squared y to the 4th cube root of xy squared. So if you're looking at this, what I could do instead is just go from this top purple one to the pink. So what I do is I take 3 goes into 6 2 times, right? 3 goes into 6 2 times. Actually, I go from here to here. And then so 3 goes to 6 2 times, so it's x squared, right? I have 2 groups of 3's in here. For the 12, I have 4 groups of 3, right? 3 goes into 12 4 times. And notice how if I break it down, that's exactly what I have. So it's just kind of like a shortcut if that's something you want to do. Okay, so but it should be 3x squared y to the fourth cube root of xy squared. And I do need to see some work of how you break it down. So just something like this or something like this as well. Number 12. So we have 3 over 3 minus square root of 2 when we need to simplify. So this is one where we can't just multiply by square root of 2. We have to multiply by the conjugate. The conjugate has the same term, but the opposite sign in the middle. So we're going to multiply by 3 plus square root of 2 and 3 plus square root of 2. So then we distribute. So this becomes 9 plus 3 root 2. The denominator is, so the reason why we use a conjugate is because really this is our a minus b times a plus b pattern, and that's a squared minus b squared. So I can write this as 3 squared minus, right, I'm just following it, so a is 3, b is square root of 2 squared. So let's simplify that. 3 squared is 9, and then the square root of 2 squared, that cancels out, so that's just 2. So it's 9 plus 3 root 2 over 9 minus 2, which is 7. And we can't simplify further than that. There's no radical in the denominator anymore, so that is perfect. Again, this is a perfect example of the work that I would like to see on your paper. Number 13, this is simplifying. So first you need to simplify what's in the square root, right? The only way to add square roots is if they are like. And then remember with to simplify, the exponents in the inside should be less than the index, right? So less than 3. So there are things in here that are more than 3, and so we need to break it down. And so how do you show the work for that? So 27 is 3 to the third. X to the fourth, I'm going to break that down as x cubed times x. That's x to the fourth, and then y third. Then we have 3y cube root of, I'm going to break it down again, x to the third, x to the first. So now I can circle everything that'll come out, right? Anything with the third power will go to the outside and multiply to what's outside. So this is going to be negative 2 times 3 times x times y, and we're left with cube root of x, plus 3, and x comes out, times y, and we're left with a cube root of x. So negative 6xy cube root of x plus 3xy cube root of x. Now they are alike. Now you may add them together. So negative 6xy plus 3xy is a negative 3xy cube root of x. So as here, this is an example of showing full work on your paper. So next, let me do number 14. So here we have a square root and an x. So we want to be able to get rid of the square root. Nothing's multiply it. So remember, to get rid of it, we're going to square both sides. So that gets rid of the square root. So we have 30 minus x equals x squared. Now remember, with a quadratic, you need to set it equal to 0 in order to solve. So we're going to subtract 30 and add x to both sides, and then write it in standard form. So you have x squared plus x minus 30. So now you need to factor what multiplies to negative 30 that adds to a positive 1. So that's going to be 6 times negative 5, right? 6 times negative 5 is negative 30. 6 plus a negative 5 is a positive 1. So this factors to x plus 6, x minus 5. Then using zero product property, we know that x is 6, x is negative 6, and x equals a positive 5. So now you need to check your solutions by plugging it in. So check negative 6. And so we want to check in the original. So before all of these changes to see if it's true. So square root of 30 minus a minus 6, does that equal negative 6? So this is going to be square root of 30 plus 6, square root of 36. Square root of 36 is 6, but that does not equal negative 6. So therefore, negative 6 is not one of our solutions. It's extraneous solution. So let's try x equals a positive 5. Square root of 30 minus 5, does that equal 5? So square root of 30 minus 5 is 25. So 5 does equal 5. Therefore, x equals 5 is our solution. So we have one solution, which is 5, and the extraneous solution is negative 6.